A hydrogen-like atom of atomic number Z is an excited state of quantum number 2n. It can emit a maximum energy photon of 204 electron volt. If it makes a transition to quantum state n, a photon of energy 40.8 electron volt is emitted. Find n, z and the ground state energy for this atom. Also calculate the minimum energy that can be emitted by this atom during d excitation. The ground state for the hydrogen atom is minus 13.6 electron volt. So now for this problem, we say that energy for an orbit of a hydrogen-like atom can be written as E, which is equal to minus 13.6 z square by n square. So over here, the question is saying that the transition is taking from 2n orbit to 1 orbit. So the maximum energy can be written as 13.6 z square 1 by 1 square minus 1 by 2n square. So this is going to be the value of maximum energy, and which is equal to 204 electron volt. So over here I can say that the first expression is going to be like 204 electron volt is equal to 13.6 z square 1 by 1 minus 1 by 4 n square. So this becomes my first equation for this particular problem. Now if it makes a transition to quantum state n, a photon of energy 40.8 electron volt is released. So now I am writing equation for the transition from 2n to n. So if we are writing transition from 2n to n, the same expression can be written as 40.8 is equal to 13.6 z square 1 by n square minus 1 by 4n square. So this becomes my second equation for this particular problem. Now, if we solve these two expressions for z and n, first of all we can divide the expression and then solve for n, and then after obtaining the value of n, we can put the value of n and solve for z. So we obtain the two values as the value of z is obtained as 4 by solving this equation, and the value of n is obtained as 2. So the orbit number which the question is talking about is 2n. So we write it as 4. So orbit number is equal to 4. So now the question is asking calculate the minimum energy that can be emitted by this atom during d excitation. So for minimum energy, so I am writing for minimum energy, the transition must be taking from 4 to 3. So n equal to 4 to n equal to 3, the transition is taking place from n equal to 4 to n equal to 3 for minimum energy, and we can write this expression as E equals 13.6 into z square, that is 4 square 1 by 3 square minus 1 by 4 square. So from here we can solve and obtain value equal to 10.5 electron volt. So this is corresponding to the minimum energy which this question is talking about.